Okay, are you ready for an epic fight between two prehistoric predators? Well, hang on. Look at this creature. You know it. An ancient shark about 65 feet long that used to swim through the dark waters of the world's oceans and was so terrifying it had no enemies. Well, almost. Scientists have recently discovered the remains of another ancient predatory fish off the coast of Australia, a fish that lived around the same time as Megalodon. It was small, about the size of a dolphin, but it could pose a danger to the infamous shark. How is it possible if this creature was many times smaller? Well, let's take a look. This monster is called Geological, and technically it wasn't exactly a fish. It was a distant relative of the modern baleen whale. Outwardly, it may seem quite cute, similar to that baleen whale I mentioned, but you wouldn't want to meet it in the ocean. It had the massive skull of a whale, large eyes the size of tennis balls, and a short snout with an immensely powerful jaw filled with razor-sharp teeth. In other words, it was like a shark version of the baleen whale. Geological lived during an ancient period called the Oligocene, which was about 33 to 23 million years ago. At that time, there was an incredible abundance of life in the world's waters. Giant penguins, small whales, sharks 2 to 3 times larger than modern ones, primitive dolphin species, and many other unusual creatures. Now imagine that in this ancient and terrifying neighborhood, a giant Megalodon met a Geological. At first sight, it's not love. The Megalodon's victory is obvious, but don't rush to write the Geological off. It's agile and fast. It's quite possible that it was more mobile than Megalodon, and during the fight, it would have avoided a direct attack. The Megalodon would have lost sight of such a small opponent, while the Geological would have swum up to the shark's belly and opened its jaws. They're small, but there are a lot of sharp teeth. Now, these teeth were designed to rip and cut. The Geological would attack the Megalodon with a small but very unpleasant bite, and the shark would have swum away after such a punch. But who knows? Maybe Megalodon would have immediately eaten Geological in the first seconds of the fight. Megalodon could have won, but in terms of speed and mobility, it would have lost. So let's look at something bigger, something that could actually have competed with Megalodon. It doesn't have to be a monster living at the same time as the ancient shark. We can make our own rules. Imagine that all ancient marine creatures ended up in the same pool with Megalodon. So its next opponent is the Liopleurodon. Now initially scientists thought that this monster could grow to be 82 feet long, which is even larger than Megalodon. But more accurate studies have shown that it only reached 32 feet, which is about the size of a modern orca. The Liopleurodon lived in the waters of Western Europe around 160 to 155 million years ago and shared territory with other dangerous reptiles such as ichthyosaurs and plesiosaurs. Yes, it was smaller than them, but it had one big advantage. The Liopleurodon possessed one of the largest jaws in the animal kingdom, which accounted for about 20% of the total length of its entire body. That's a mouth. Its jaws were about 6.5 feet long. A huge, toothy mouth the size of an adult basketball player filled with smooth and dagger-sharp teeth, ideal for cutting steaks and peeling ammonite shells. And by the way, scientists suspect that ammonites and squid were the creature's main diet. This super predator was also a very fast and agile creature that ambushed and attacked its prey from below. Megalodon would have been in big trouble. The grip strength of a Liopleurodon would surely be more powerful than that of Megalodon. Besides, the Liopleurodon's size and mobility would allow it to attack the enemy from different sides. It's probably why Megalodon would have lost in that fight. The next opponent for our Megalodon is the Dunkleosteus, and to be honest, this guy has almost no chance of defeating the large ancient shark. But the Megalodon probably wouldn't have beaten it either. The Dunkleosteus was one of the earliest predators of the ocean. It lived in the late Devonian, about 382 to 358 million years ago. Its size was about 13 to 32 feet or even less, and it also had no teeth. What? A predator without teeth? How did it survive in a dangerous prehistoric world? Well, it grabbed and chewed food with the help of special jaw growths. Those growths were so powerful that they could pierce steel, if there was any around. In a sense, these were not teeth, but bones. Okay, let's say the Megalodon grabbed this predator by the belly and it couldn't do anything with its growths. But the problem is that the Megalodon would have hardly done anything either, because the Dunkleosteus was a heavily armored fish. Just look at the shell. It probably limited its mobility, but it provided incredible protection. This monster felt like a big stone in the teeth of the Megalodon. It's unlikely that the Megalodon would have wanted to chew this stone. It would have spit it out, and both predators would have gone about their business. We've got a draw here. And now, the final match. Here's the next opponent. You see anything? Is this enemy invisible? What's happening? Ah, there it is. Meet the Tullimonstrum. It's a tiny ancient monster, just 11 inches long. Huh? What can it do to a giant shark? Next to the Megalodon, the Tullimonstrum is like a box of matches compared to a human. But if the Megalodon had had a developed brain, like people do, it would have been very scared of this creature and would have immediately swum away. Many people scream and run away in fear when they see a creepy insect crawling or flying, or when a mouse runs across the floor. Some of us jump on the couch in horror. Not all of us, but some. The Megalodon would have jumped out of the water like a dolphin if the Tullimonstrum had charged at it. Just check it out. It looks like an underwater bike with a long trunk with a jaw at the end. And these handlebars, where you would put your hands to control your bike, are the eyes. It's like the eyes of a hammerhead fish, only thinner and longer. The body of a squid, cuttlefish fins, snail eyes, and a toothed proboscis. This is a horror movie character. Scientists say it probably hunted jellyfish, small fish, and shrimp. And it didn't chew the food, it licked it like ice cream. Obviously, it's not an opponent for the Megalodon, but it's still a creepy monster. Well, what would have happened had it really started a fight with the Megalodon? It would have been difficult for the ancient shark to find it. It would have been unlikely to catch this tiny monster in the mouth, and the Tullimonstrum wouldn't have been able to do anything to the Megalodon either. However, I can think of one strategy. The creepy creature had a long trunk. What if it had just swum under the Megalodon's fin and started licking it? If the shark had felt the tickles, then it would probably have worked. But most likely, they wouldn't have fought each other. It seems like they would have made perfect friends. The Tullimonstrum lived about 300 million years ago in shallow seas and estuaries that covered the territory of the U.S. When scientists discovered this creature in 1955, they were shocked because no one had any idea what it was. Experts compared it to worms, tunicates, conodonts, mollusks, and vertebrates. And do you know who it really was? Well, scientists still have no idea. They can't determine its place on the tree of evolution. Perhaps this is some new branch, and its descendants simply haven't survived to this day. The Megalodon was one of the most dangerous predators on Earth. But now we know that other equally scary monsters lived in the oceans. But what if the Megalodon lived today? Who could have defeated him? A blue whale who would be even bigger than this ancient shark. But the blue whale seems to be a kind animal. It wouldn't fight. How about the Kraken? The Kraken versus the Megalodon? Well, let's save this fight for another video. Well, you can toss out those chocolate frogs from Harry Potter. We have real ones now. Well, they certainly wouldn't taste as good since they only got that nickname because of their skin, which is the color of milk chocolate. These frogs live in the swamps of New Guinea, but they're close cousins of green tree frogs common for northern and eastern Australia. Now, Australia and New Guinea were connected by a land bridge a long time ago, so they have similar kinds of animals. This chocolate frog is smaller than its green relative, but both species have the same call for mating, which sounds like a deep, rasping bark they repeat in long series, which I won't do here. Local people from a small island in Africa helped scientists find a new kind of Scopes owl. They're probably descended from the first owls that came to this area a long time ago. Although they come in assorted colors, they're mostly brownish, which is why they easily blend in with trees, so you hardly even see them. They're also really small, and they have a call you won't hear anywhere else. It sounds like a short "too" note they repeat fast, as if it's an insect producing this sound. You can hear them making these calls in duets as well once night falls. They might be called endangered species, considering they live in a small area of around 6 square miles, and there are up to 1,500 of them. The Sunda flying lemur is a kind of gliding mammal you can find in Southeast Asia. It has a small head, small ears, and adorable big eyes that help the animal see well in the dark and move at night. This little one is not a real lemur. It falls into a category called cologos. Even though its name says differently, this creature can't really fly. It can only travel long distances, which is not bad at all, considering it can glide for up to 328 feet without losing too much altitude. Its special skin fold makes it easier to glide between trees, and its lightweight skeleton and webbed feet help as well. This cute animal is small, less than 2 feet long, and it weighs up to 4 pounds. Plus, it can camouflage well because of its dense and mottled fur that resembles tree lichens. So once upon a time, more than 160 million years ago, I wasn't around then, there was a spider that kind of looked like a pelican. As big as a grain of rice, it would sneak around in the leafy areas of our planet and look for prey it could catch with its fanged pincers placed at the end of its long neck. It especially liked to eat other spiders. This tale has a happy conclusion, well, depending on the perspective. These fellows still exist, and they're far more diverse than anyone expected. When it's not going after its prey, the pelican spider just folds its pincers down against its long part like a neck. This makes it look more like a bird than a regular spider, and that's how it got its name in the first place. These creatures are different from most other spiders because they don't make their own webs. Instead, they just look for the trails of silk other spiders left behind in the leaves and follow them. When they find a web some other spider made, they patiently wait for the right time to strike, which is how they got the proper nickname, assassin spiders. So it's not unusual for hermit crabs and sea anemones to team up. Anemones have stinging tentacles, and they use them to protect crabs from predators. In return, they get a free ride to places they haven't seen before, and some leftovers crabs share with them. But off the coast of Japan, scientists found this new anemone that does something extra special. Not only does it live on a hermit crab's shell rent-free, but it also creates a covering that goes over the shell. In a way, it adds a porch to the crab's house. It's not something you'll see very often, because most sea anemones don't go to such lengths. Now, what's even cooler is that they won't build these extensions for any crab out there. They have a specific partnership with only one hermit crab species. If a crab wants to move to a new shell, its friend joins it. This type of anemone is called a calcifer, after a character in Howl's Moving Castle. Calcifer is a fire demon bound to the wizard's castle by a magical pact. This castle moves from place to place, like a hermit crab. In 2020, researchers found a very long animal that looked like it was made from gelatin. It happened around 2,000 feet under the surface in a deep canyon off the coast of Western Australia. They were exploring the ocean floor, trying to find signs of life there. They didn't find this creature on purpose. They unexpectedly stumbled upon it as they were heading back to their ship, and it turned out to be a type of deep-sea siphonophore. It's related to the Portuguese man-o'-war, those blue bottles you might see floating on the surface of the ocean. These animals are not a single organism. They're made up of many smaller parts that work together. We call them zooids. Some zooids are there to help with reproduction, while others oversee feeding or moving through the water. These unusual creatures mostly look like twisted and tangled feather boas. Its spiral shape is its hunting technique. The siphonophore has many stinging tentacles that form some type of barrier in the water and trap small animals such as fish and crustaceans. The scientists didn't have much time to examine the creature, but they noticed that it was the longest siphonophore they had ever discovered. It could be longer than a blue whale. Wow! Now, here's a little creature you don't see every day. They're called tree hoppers, and they spend most of their time on plants and trees. They're not longer than a dime, but you can find them in different shapes. Some look like tiny helicopters, while others are more like leaves, thorns, or even raindrops. There's a thing called a pronotum. That's like a small plate other insects have too, and it resembles a shield. Tree hoppers are real artists here because their pronotum gives them these bizarre shapes that make them stand out in the animal kingdom. And since they have such a weird shape, it's easier for them to stay safe from predators. Their barbs and spines warn other animals that tree hoppers might be tough to swallow, so they might not be worth catching. Bright colors are not that attractive either, since they tell predators there might be toxins in the body of their potential prey. Plus, they're good at mimicry, the art of pretending to be something else. Their big pronotum are light and hollow, so they can easily fly. They communicate with each other by sending vibrations through plants. You won't hear them making loud sounds like some other insects. Tree hoppers prefer to shake their bodies to produce vibrations we humans can't hear. Interestingly, they use such a form of communication to protect their young. Many other insects just leave their eggs alone, but tree hopper mothers stick around and watch over their eggs. When something dangerous, such as a stink bug, comes closer, a young tree hopper sends out a vibrating signal. Its siblings quickly notice this signal and join in, which is how they make the warning stronger. The mother receives the messages and gets into action. She either buzzes her wings very loudly or uses her back legs to defend her kids from the intruders. They're like mosquitoes in a way. It's just that they use their special mouth parts to pierce not people, but plant stems where they take their juices. Weird and wonderful, all in the same package.
In 2021, while drilling about 11 feet beneath the surface of permafrost in northeastern Siberia, researchers uncovered a 24,000-year-old frozen life form. And then, they brought it to life. Before cloning it, or better said, it cloned itself. This might sound like the beginning of a sinister horror story, but don't worry, it's actually quite the opposite. What scientists unearthed was a microscopic frozen organism that could fundamentally reshape what we think about evolution and survival. The uncovered tiny creatures are called bdelloid rotifers, microscopic animals with little wheel-like mouths that they use both for moving and feeding. They were first discovered in 1696 and are fairly common in freshwater environments around the world, with a few saltwater species. They might seem unremarkable, but scientists have been studying them since early microscopes made it possible to actually see them. Because even though there are only a few dozen microns wide, they're surprisingly complex, with brains, guts, muscles, and reproductive systems. Could it be that within that complexity lies the secret to ultimate resilience, maybe even for us humans? Let's break it down. These creatures are extremophiles. That means they can survive being completely drained of water at any point in their life cycle, then lie dormant until rehydrated. But that's not all. They can also persevere through some of the harshest conditions on Earth, or in outer space, or even being stuck in the Siberian permafrost wasteland for tens of thousands of years. This is possible because they can enter cryptobiosis, a condition where organisms pause their metabolism and become nearly inactive. It may sound sciencey, but actually, some of the everyday products we eat are stored in a fridge thanks to this phenomenon. Take yeast, for example. Live yeast cells are surrounded by a protective layer made of dead cells and some nutrients. You can keep yeast at room temperature, but if cryptobiosis comes into play, in the form of your fridge or freezer, It stores much better and longer. During cryptobiosis, rotifers accumulate protective compounds like chaperone proteins, which help them repair and recover once favorable conditions return. Chaperone proteins are like tiny bodyguards. Their job is to keep other proteins in the cell from falling apart under pressure. When the body is stressed, whether from heat, cold, toxins, dehydration, or just the natural aging process, the proteins inside our cells can start to misfold. Proteins need to be folded into very specific shapes to function properly, and when that structure breaks down, they become useless, or worse, harmful. Misfolded proteins can pile up and interfere with normal cell function. In some cases, they clump together in ways that poison the cell. This kind of damage is even linked to serious health conditions. So, if rotifers have developed powerful proteins that prevent cellular chaos even under extreme conditions, could we use them to protect human cells from diseases and aging? By analyzing the age of the ice they were found in, scientists figured out that these frozen rotifers were at least 24,000 years old. That's a huge leap from earlier studies, which showed they could survive frozen for only about 10 years. Now that's what you call record-breaking. This period of Earth's history is known as the Late Pleistocene Epoch, a time dominated by the Ice Age, which means these invertebrates were lying dormant when Manny and Sid were having their adventure while roaming the icy landscapes, along with saber-toothed cats and giant ground sloths. Fun fact: although animated movies like Ice Age show woolly mammoths as huge, towering giants, they were actually about the same size and weight as today's average African elephant. Nature and evolution can be so cruel, yet fascinatingly unpredictable. Massive, menacing beasts that came from the Ice Age couldn't survive it, yet something tiny and weird, like a bdelloid, could. But regarding our unfrozen creature, after the soil thawed, the organism didn't just begin moving again, it also started reproducing. This is thanks to an ability called parthenogenesis, a specific form of reproduction in which embryos develop from unfertilized eggs, allowing them to reproduce independently. It really is like cloning, but it happens naturally. Many organisms, such as certain insects, reptiles, and even some birds, are capable of parthenogenesis, at least under specific conditions. For example, in honeybees, males develop from unfertilized eggs through parthenogenesis, making them genetic copies of their mother. However, parthenogenesis is often seen as an evolutionary disadvantage because it limits genetic diversity, meaning that most species that reproduce this way eventually face extinction. Despite this, bdelloid rotifers have diversified into over 450 distinct species over millions of years, which is extremely rare. Scientists believe their survival comes down to a few evolutionary adaptations. They can pause their metabolism through cryptobiosis, repair their DNA with specialized proteins, and even borrow useful genes from other organisms using a process called horizontal gene transfer. Unlike most animals which rely solely on inherited DNA, these organisms can steal genetic material from bacteria, fungi, and even plants, splicing foreign genes into their genome to gain new survival traits. Some studies have shown that up to 10% of their active genome comes from foreign DNA. This could explain their extraordinary resilience. They borrow genes for stress resistance, toxin breakdown, or radiation repair, essentially patching and upgrading their DNA in real time. It's not like the Mind Flayer from Stranger Things, where the creature absorbs another organism to improve itself and grow. It's more like a spy stealing a blueprint from a rival lab to learn its secrets. When cells rupture, for example, when bacteria die nearby, bdelloids scoop up loose DNA fragments and integrate them into their own genome. Interestingly, the usual expected lifespan of bdelloid rotifers under normal circumstances is only 2 weeks. The soil sample that contained these rotifers also held nematodes or roundworms, another group of tiny survivors already known to withstand tens of thousands of years icebound. This isn't just limited to microscopic animals. Researchers have successfully regrown Antarctic moss and entire Campion plants from seeds and samples frozen for hundreds or even thousands of years. In 2016, a team of Japanese scientists brought tardigrades, or simply water bears, back to life after 30 years in cryptobiosis. Tardigrades are even more impressive because they can live in a suspended state for up to 30 years, without food or water, and with temperature swings from deep freeze to 300 degrees Fahrenheit. These guys can also endure crushing deep-sea pressures, vacuum, microgravity, and intense radiation of space. Remember when we said earlier that these species can survive the harshest conditions on Earth and beyond? It wasn't an exaggeration, and now you understand why. And it's exactly why NASA and its partners sent water bears and bedelloid rotifers into orbit. They've even been aboard the ISS, helping scientists understand how these animals handle microgravity, radiation, and stress. Not only that, but in 2007, the European Space Agency launched a bunch of tardigrades into low Earth orbit, completely exposed. No suit, no shield, floating in a vacuum. They were blasted by cosmic radiation, UV light 1,000 times stronger than what hits Earth's surface, and temperatures near absolute zero. And when they came back, most of them woke up and reproduced despite the harsh conditions they were exposed to. This ties into an old theory called panspermia, the idea that life didn't originate on Earth but arrived here, locked in space dust or trapped inside a meteorite. Before, maybe it sounded like a fringe science, but when organisms can brush off cosmic radiation, then it doesn't seem so far-fetched, does it? What about humans? Does this mean we now fully understand the way hibernation works and are close to putting humans in this state? Sorry for spoiling it for you, but it still feels more like science fiction. However, researching rotifers, water bears, and similar organisms can lead to massive breakthroughs in other fields. Their resilience might be a blueprint for medicine, for reshaping what it means to age, maybe even to pause life itself, or extend it. We're talking real, practical innovations, from better preservation of human organs for transplantation to drugs that slow aging at the cellular level. And yes, maybe even cryogenic hibernation, long enough to make interstellar travel possible.
There's a creature somewhere deep in the ocean looking for prey that would make Dracula himself proud. It's been around since before even the dinosaurs walked the earth. It has no bones or jaw, but it doesn't stop this underwater vampire from hunting. The name of this eel-like parasite is the Pacific lamprey. The English monarch loved this fish so much that he defied doctors' orders to stop eating lamprey flesh. He got sick every time he'd have the original gooey fish. But the lack of bones and the fact that this lamprey tastes like slow-cooked beefsteak made the royal fall in love with the fish once and for all. The product of this love was a chill in his aged body, some heavy sweating, and some other scary symptoms, which eventually took his life and interrupted his 35-year reign. The lamprey is way better at surviving, as it lived through at least 4 mass extinctions. Its ancient ancestors evolved over 450 million years ago. There are around 40 living species of lampreys still thriving across the world. The Pacific lamprey is just one of them. These creatures have cartilage instead of bones, and a third eye, which is a special light-sensing organ on the top of their heads. Instead of a regular jaw, they have a sucker mouth surrounded by teeth. It's perfect for latching onto prey and sipping up body fluids like underwater vampires. Once they pick a victim, they suction it, making a seal that's almost impossible to break. Scientists believe the Pacific lampreys don't munch on flesh. Female lampreys lay up to 200,000 eggs in nests that stay in fresh water for 3 to 4 weeks. Once the larvae hatch, they burrow into sediment and stay under the sand for up to a decade. When they hit their teenage years, these miniature Draculas re-emerge and migrate from freshwater all the way to the Pacific Ocean. This journey isn't the easiest, and it takes some changes to its appearance and physiology to adapt to a huge change in salinity. After several years, they go back to freshwater to reproduce. Pacific lampreys can use chemical clues released by their larval migrating pals to find their way. They can travel hundreds of miles inland to find the perfect spot for spawning and rearing. It's not always the same place they spawned in. Many species of birds, mammals, and other fish can appreciate the fatty flesh of lamprey. This makes them some of the most valuable players in freshwater and marine ecosystems. Another lamprey type, the sea lamprey, is native to the Atlantic Ocean. It's not that dangerous when it's at home, but once it gets to the Great Lakes, it becomes a real threat to the 4 local native species of lamprey. The sea lamprey is up to 4 times bigger than the lake species. It has unlimited food and spawning grounds, and no natural predators here, so it becomes cocky. It secretes an enzyme that doesn't let the blood clot. Once it attaches to some unsuspecting fish, it spends the next several months feeding off of it. And even if the fish shakes the lamprey off, it doesn't have long to live because the mark the predator leaves behind. Sea lampreys aren't interested in humans, but can accidentally latch onto a swimmer. It won't be fatal, but it's not the most pleasant sensation, and you need to get the spot of the impact disinfected. The Australian box jellyfish looks harmless, but it's considered the most venomous marine animal. Unlike other kinds of jellyfish that float with the current rather than swim, this creature can reach an impressive speed and choose its own direction. It has tentacles covered with tiny darts loaded with poison. People and animals that get unlucky enough to meet with those tentacles face some scary and sometimes even fatal consequences in a matter of minutes. Before you decide to never revisit the ocean, you should know that only a few out of around 50 existing species of box jellyfish have venom that is lethal to humans. There are some not-so-dangerous species living in warm coastal waters worldwide. And the most dangerous ones are in the Indo-Pacific region and northern Australia. A blue-ringed octopus spots a signature psychedelic color and the ability to take away your life. This cute-looking sea monster likes to spend its time in the soft, sandy bottom or shallow tide pools and coral reefs. It normally hides in underwater crevices, among shells or debris. If you disturb it, the octopus will activate its tiny color-changing organs and demonstrate its blue rings as a warning signal. The next step will be releasing a venom 1,000 times more powerful than cyanide. This venom is more toxic than that of land mammals. The octopus normally uses it to hunt crabs, shrimp, and small fish by pecking them with its beak and paralyzing them. There is no known antidote for the venom, so if you ever see this sea creature, the best you can do is to stay away from it. It bites without any pain, so you might notice when it's too late. The good news is that it's not aggressive and won't go after you unless it's cornered. The reef stonefish are masters of disguise in the underwater world that camouflage themselves on rocks, coral reefs, or just blend into the seabed. They thrive throughout tropical marine waters of the Indo-Pacific. Their invisibility superpower makes them especially dangerous to their prospective victims they ambush and swallow whole. If someone happens to disturb them, their 13 defensive dorsal spines stand on end and deliver a powerful venom punch. They say stonefish stings are extra painful and lead to scary consequences within minutes. They're called the most venomous fish in the world. If you don't do anything about it, the impact can be lethal. If you ever go diving in the Pacific Ocean, be careful not to pick up a cone snail from the seafloor. It has a beautiful shell made of brown, black, or white patterns. Like most other snails, it's slow, but it has a complicated system of seeking out prey. It likes to snack on fish, marine worms, or even other snails. Once a cone snail senses food is near, it activates a sharp proboscis, or a needle-like protrusion from its mouth. The attack is swift and super potent. The victim doesn't even have time to realize what happened to them. Once it's completely incapable of moving, the cone snail swallows it whole. Humans aren't on its menu, but it can still release the venom if someone steps on it or disturbs it. The proboscis can even penetrate gloves. Luckily, only several out of over 700 species of cone snails can take a human's life. But since there's no antivenom, you better not risk it. All 52 known species of sea snakes living mostly in the warm tropical waters of the Indian and Pacific Oceans are venomous. The beaked sea snake even has the title of one of the world's most venomous serpents, but it's one of the few kinds that can pose a real threat to humans. Sea snakes prefer a peaceful coexistence and would rather slither away than engage in any confrontations. If you ever see them in the water, staying calm and moving slowly will save your life. Sea snake bites, although almost painless at the moment, can have varying degrees of impact. Some may only cause mild symptoms, while others can lead to severe outcomes. Most bite reports come from accidental encounters, like someone freeing them from nets or unsuspecting beachgoers stepping on them. Blue dragons rarely grow larger than the size of a grape. They like to swim belly up, so their brightest blues blend in with the ocean waters. And the silver front faces down and camouflages with the darker seabed. Blue dragons feed on another dangerous sea creature and store up their stinging cells. Their venom lives on even after the fish itself is no longer alive. That's why you should be extra careful and never pick up or step on them on the beach.
Something exciting and kinda unexpected popped out among the rocks of the Ica Valley in Peru. The bones of a really old whale that lived almost 40 million years ago. At first, no one was really impressed because the bones they found were big and weirdly shaped, so people just thought they were looking at giant boulders. I mean, that's cool too, but things got way better when they realized those were the remains of a very large ancient animal that roamed along the coast of ancient Peru. Plus, it was probably the heaviest creature that ever lived. Sorry, blue whale, I know you worked hard to get to the top. The length of over 100 feet and weight of more than 200 tons brought you the status of the biggest animal on our planet. But it seems you've held the title long enough. Time to hand it over to our next candidate, and that one's really gigantic. This ocean beast was probably shorter than the blue whale, but heavier, with a weight that could be between 93 tons and 370 tons. If it's closer to the higher number, it'll make Perucetus the biggest animal ever known to have lived on Earth. And it seems its weight was the result of having extremely thick, dense bones. You can see such bones today in manatees or some other early whales. Dense bones are a great tool for such marine mammals. This feature makes them heavy and allows them to stay submerged most of the time. But at the same time, if their body was too heavy, they would end up sinking all the time, and they would waste too much energy to move back up to the surface. So, to avoid sinking, marine mammals need to have enough lighter tissues, like muscles and fat, to help them float in the water without using too much energy. Now, scientists didn't have the whole skeleton, which makes it hard to tell how big the animal was. But they used the ratio of the heavy bones to the lighter tissues in other marine mammals to estimate the overall weight of this giant ancient whale. Experts found these fossils about 13 years ago and spent the next decade freeing the whale from the rock. Its anatomy and age showed this whale was a cousin of Basilosaurus, a whale that had a long snout full of sharp teeth, and a sleek body similar to that of an eel. Even if Perucetus wasn't bigger than the blue whale, it was still a giant that ruled the ocean depths. Unlike modern whales, there's a possibility that this ancient fellow was a predator that liked to go after bigger prey. And this also changes how we see the history of whales. Scientists used to think these magnificent creatures became really big about 5 million years ago when they started eating lots of small creatures. But here's the proof that giant whales existed even before that. But it's still unclear how this whale managed to find enough food to sustain its enormous body. Plus, it's still hard to tell what exactly this ancient creature had on its menu. It was pretty large and not such a fast swimmer, so it's possible it searched for food in shallow waters. Then it probably ate crustaceans, clams, or some other small animals hiding in the sand. One theory says it was a scavenger, which basically means it munched on remains of everything that would come its way. It's not so unusual to find marine animals in deserts.
Many of these regions used to be covered with water anyway. The Sahara in Africa is a perfect example. About 50 to 100 million years ago, this was not a dry desert, but a shallow saltwater body called the Trans-Saharan Seaway. The land is not wet there anymore, of course, but people who lived in that area knew about it because they used to find old shells across the desert. The sea was about 164 feet deep. That sounds enough for a nice swim. Some would say this area looked like modern Puerto Rico, with lots of sun and shallow water. Mangrove forests were a common thing, as well as seafloors covered with mollusks, like snails and clams. The marine sediment that was left behind after the sea had dried up is full of different fossils. And the animal that lived in that ancient underwater world didn't look friendly. Plus, they were much bigger than their relatives from modern times, so a regular-sized human would end up as a snack, not even a whole meal. Normally, when animals live on small islands, they can become much bigger than their relatives from the mainland. This is something we call island gigantism, and it happens because there are more resources or fewer predators on islands. Maybe the same thing happened in the Trans-Saharan Seaway. Even though it wasn't an actual island, the water moved in and out, which created little pockets of water. And specific conditions in these pockets might have helped animals grow bigger. So we're talking about giant sea snakes, catfish, and fish that no longer exist today. One had incredibly strong jaws, and the animal used them to eat hard things and even crush shells. Their teeth showed they were fierce predators other animals had every reason to be afraid of. They went through some changes when it came to diet, similar to some types of piranhas. And the competition to get to the top of the food chain wasn't a joke. Not when there were also such large predators as sharks, crocodiles, and ancient relatives of elephants. Sahara went through different phases. If you could use a time machine and take a peek at Earth's largest hot desert as it was about 6,000 years ago, you wouldn't have to struggle with sand and heat. You'd have a nice walk through a green and pretty lush place. In the past, people who lived in that area didn't leave drawings on cave walls that showed camels, sand dunes, and scorpions. All those things you'd see in today's Sahara. Instead, they drew crocodiles. That's additional evidence that the Sahara used to have a lot of water and plants, enough to support these big yet scary animals. Around 3 billion years ago, Earth might have been mostly covered with water. Today, it's about 71% of its surface, but it seems that our planet used to be a giant ocean world with no continents at all, just some scattered islands. Scientists studied special rocks in Western Australia that formed in a place deep under the ocean called a hydrothermal vent system. To explain this better, it's important to mention two common oxygen types, O16 and O18. O18 is heavier because it has extra neutrons. O16 evaporates from water more easily, and as researchers studied an old ocean floor, they found a lot of O18, more than in today's oceans. This way, they realized ancient Earth had less dry land than Earth today. Australia is a good spot to conduct these studies because a long time ago, it also used to be a beautiful place with large animals and lush rainforests. But as time went by, the land became drier and Australia had more deserts formed, such as the Great Victoria Desert. Rainforest remained only on the edges of the continent. What happens with deserts across the globe is called desertification. That's when land that used to be good for growing things turns into a desert or something similar. Our planet changes over time, together with its climate. But desertification also happens because of human activities, like mining, farming, and building cities. And when land turns into a desert, it's a problem because it can't support people and animals anymore. Food doesn't grow there. There's not enough clean water, and animals lose their homes. To help with this problem, there's a plan many countries agreed to. They decided to work with farmers to take care of the land, fix damaged areas, and manage water better. All in all, to make our planet a better place for life.